Okay, year 13, a little bit of a different video here because I've got the calculator emulator set up on the left hand side of the screen. So we're going to have a look at working through some of this investigation with you if you're struggling with the more advanced calculator use. So it's nice to see what's going on the left hand side here so you can follow along. So we're going to be drawing some graphs of some trig functions and seeing what effect some variants of these equations might have on the look of the graph. So we're going to have a look at our graph function, obviously on the calculator here. So turn your calculator on and you can scroll down to the graph function, or you can directly press 5 to get onto the graph function. You can see from the PDF here that we're going to be drawing the graph of sine of x. So we can start to type that in. A really important thing to remember though is when we're drawing graphs, we don't want to use the alphabet X. So you don't press alpha in red and then the plus to get the X up there. We need to use this key over here, X theta t. This is our variable key. So whenever you're drawing a graph where the variable might change, you need to use this button here. So this will give us an X for our function. And then I'm going to veer off slightly from the PDF here because I'm going to show you if you press EXE then it locks in that function, and if I press EXE again or even F6 because it's got draw underneath it, we're going to draw the graph. So here's our graph of sine x. You might notice some differences from what we've seen before because actually this graph peaks somewhere between 1 and 1.5 and then it also has a lower point sort of around 4 to 5, close to the 5 point, then comes back up to the x-axis just after 6. Well, we know this shouldn't be the case if we're looking at our normal sine x graph, and this is because our calculator is actually in radian mode by default. So we need to make sure that our calculator is set up in degrees. Yours might already be in degrees if you've been doing Miss Ahmed's trig functions, or if you were remembering from our last online lesson just after the test that we've got the radian function changed to degrees. So what we need to do, we need to go back and change the setup. So we can press exit to go back to our functions here, and then shift and menu to get the setup. And you need to use the cursor keys to scroll down here until we find our angles. So angles there, you can see it's rad for radians there. We need to change it back in degrees, so you can press your F1 button to get that. So this should now have our graph drawn in degrees mode. So let's exit, and we've got sine x, so let's draw that again. So now you can see we've got another problem is that our x-axis is actually set up in degrees here. So we've actually got the graph being shown as 1 degree, 2 degrees, 3 degrees, 4 degrees. And we know that the graph usually has some big changes in it, but that's over 0 to 360. So we also need to change the view window we've got for the graph. So you can press Shift and then F3 to get to view window. And you can see here that we've got little options here. We've got initial, trig, standard. And then obviously if we're looking at a trigonometric graph, F2 is going to be the handiest one. So if I press EXE here, and then go back to our function screen which we're on, press EXE again to draw the graph. This should now look much more familiar. And you can see we've got it from up to 450 degrees here, and we could check if we wanted on the view window by going back to it. We've got a scale of 90, and this means that each vertical line on our x-axis should stand for 90 degrees. You could also start to change these numbers if you wanted. If we only wanted the positive numbers on our graph, we could change the x minimum to 0 by just typing in there, and x maximum maybe to 360, and you'd see a more familiar looking graph. We're going to leave it here with quite a few changes on. So exit, we can have a look at this graph, superb. But what we want to have a look at is some variants of this graph and see what effect adding or subtracting some constants will have on it. So we're going to have a look at the bottom here. It says this f brackets x plus a plus b. We want to see what effect changing a will have and changing b will have on the graph. So we need to set this up in a very particular way. We want a function of one of our original graphs. So now that we can see that the y2 line is highlighted for our second graph, and while it's highlighted, if you need to go back and scroll upwards or down to get onto there, do so. While the y2 is highlighted, you need to press on the cursor key to the right, and it gives us a few more options for drawing our graph. And we're going to need to pick y again for F1, and this means that our second graph is going to be a function of one of our other y graphs, i.e. the first one. And because we want it to be the first one, we can obviously press y1. What do we then need to do to that graph? Well, we're going to add a constant in the brackets and add another constant b on afterwards. So we need to set it up like it's got in the PDF here. So brackets, remember x here, the curly x needs to be our variable button. The a here can actually be the alphabet A, so we need to press alpha and then the variable button to get the capital A. Close the brackets, plus alpha button again, and then log to get the capital B. Now, if you press just equals in exe straight away on this, it's going to lock it in, and then you're going to have the issue that actually it won't know what we're doing with A and B here. So we need to go into a special way of drawing our graphs here, which we're going to have a look at by modifying. We've already done a view window here that's on the PDF. So we're going to select modify with F5, and this means we can change the graphs as we need to on the fly. So F5 to modify. And then it doesn't really know what to do with our initial graph at the moment because we haven't got any variables A and B. We can have in here A is 0, your B is probably 0. I've drawn a graph earlier, so I'll just set mine back to 0. And one of the other differences, you'll probably have step as 1, so let me just change that back to match yours. Now you can see then we've got a red line overlapping the blue line, and what we want to do is we want to see what effect changing A will have on the graph. So if you scroll up and down with the cursor, you'll see that you can change between selecting the steps in how many steps and how many values we're moving on. Perfect timing on that. And scroll up to B or A, and we can actually change those variables. Now you can see here, if I want to change the value of A, I can then scroll to the right to increase it by 1. A's gone to 1, to 2, to 3, to 4, to 5. You'll notice that the graph really isn't changing very much. You can just about see the red lines starting to move away from the blue one. So actually what we need to maybe do is change the steps that we're taking. If you remember, our x-axis is measuring degrees here, so we want maybe more degrees change each time. So I can scroll down again to the step, and you can straight away start to type in. I'm going to type in 10 here, then exe, to get a step change of 10. That means when I scroll back up to A and scroll to the right, then I'm now changing by 10 degrees each time. And if I keep on pressing the right hand button to change and redraw the graph, you should hopefully see that the graph's actually gradually moving to the left here. So you don't want to always jump up in major steps so that you can actually see what's going on with the graph. And then as I start to press left instead, I'm going to reduce A. You can see the graph returning, now moving to the right to get back to close to where it was in its original. So you should be able to hopefully spot that this A in the brackets, as you increase it by 10, it actually shifts our graph left to the 10, a horizontal translation. So let's have a look at what happened with B. I'm going to change A back to 0, so I've got it highlighted again and just type in the 0 straight away, and exe. And then we're going to have a look at changing B. Now again, I want to go back to small steps on this just in case. So I'm going to change the step by having it highlighted, type in 1 and exe, and then scroll back up to B. If you can see here, our y-axis, which is inevitably going to be the other change we get on our graph here. If the first affected our x-axis, the other variable will probably change our y-axis. So if I go in a step of 1, and then I'm going to press the right cursor, and you can see the graph has floated upwards by 1 unit. And then if I press it again, we should possibly see just a little smidgen of the graph there. Then I can press the left button to scroll it downwards a bit as well. So we can see what effect changing B has. As B increases, our graph rises. As B decreases, our graph gets lower. Now, if we were then struggling here to see what we wanted, if we actually wanted B to be -2 on this graph, we can change our view window again. And there's a couple of ways of doing it. You can go into the zoom function later on, or change the view window, but we're going to need to go back because we're in the modify function at the moment. It doesn't work immediately. We're going to have to go back to our main screen to change the view window. And what you might want to do is then scroll down, and you can see here, like we've got on this area here, the Y minimum and Y maximum. We might want to go maybe to 5 and -5 on the graph. So just change those to -5 and 5, and you'd have a better view of your graph. So this should get you through having a look at what we've got going for this at the moment and changing these variables. It's a really nice function, especially with the graph transformations. And this would work for your previous chapters that Miss Ahmed covered as well on this. So we can have a look and then have a look at how the graph's affected by that function. So let's also have a look at the stretches then. So it's going to be a very similar process here. So we're going to press exit until I get back to the original functions on the graph. And we don't want them there anymore. So I'm going to scroll up to them. I'm going to delete them. So you can press F2 to delete and F1 to confirm. And then with the top one, F2 to delete, F1 to confirm. And we want to explore these graph stretches then. So I'm now going to look at y equals cos x to start this one off. So start to type in your function here, y equals cos x, and make sure you're using the variable button again. and then exe to lock it in. We want to have a look at our two transformations here, f brackets kx and kf brackets x. We're going to need to do these one at a time really, so we can see what's going on with it. So it says start with f brackets kx, and we need to input this in a certain way again. So we want our red line here, y2, to be a function of our first one. So we first off need to select that. So highlight the y2, push to the right, and then we can select the y here with f1. And then we need to put the number 1 in, so that our line 2 is a function of line 1. We can then put our brackets in, and then what we want is it to be a k times x. And again, you can use the alpha, that k. But when we use our x here, we need it to be the variable in our graph previously, and close the brackets. And as you might expect as previously now, we can lock that function in with exe, and then we can go into our modify function by pressing F5. You can see it's right underneath the F5, or sorry, right above the F5 here. So press F5. So we've got the cos graph here, and what you can see is that actually we've then got k as 0 here, so we've actually got a straight line. So what we might want to do here is go straight away and change k into 1, and then we can see our original graph here where k is 1, so we've got the graph of 1x here, or the graph of just a function of x. As you now start to scroll to the right again, you'll see the change in the graph. This is really squiggly, so you can actually see it's kind of being squashed in from our original. Let's change k to 3, even more squashed up, k to 4, even more squashed up, k to 5, even more squashed up. So you can see that this increase of k inside the brackets is squashing the graph in. It's a horizontal stretch of actually a scale factor of 1 over whatever k is. So this one here is 1/5 of our original graph. And then we can actually change k to whatever we wanted. If this is a scale factor of 1/5, then what we might imagine is if you had k as 0.5, it would actually be twice as wide. So let's see if we can get that straight away. You've got k highlighted here, so I can just start to type in 0.5 exe, and you can see how the graph changes, and yet you can see it's actually stretched out now with a decimal value of k. So you should have an idea of these stretches that happen when k is in the brackets. So we want to have a look then what happens if k is initial part of our graph function. So let's exit again, and what we're going to do is edit the function above. So you can press left and right here actually to get back into the function here, and you could put this letter k at the start, and then we want to delete the k that's in the brackets here as well. We don't want it to be twice, and you can press your delete button there to get that back. So we've now got that graph 2 is a multiple of the function of x, is the way of kind of writing that. And again, we can do our modify function on this, press exe to lock the function in, modify, and then we can start to change our graph. As you can see there, it's held over that k is 0.5 from the previous time we drew the graph, so you might want to just change that to k being 0 or k being 1, so you can see the original version of it. Then we're going in steps of 1. Let's see what effect this has on the graph. And again, you can immediately see that it's kind of got much higher. It's got the same x-axis intercepts, but the y values are going to get possibly twice as high. You might be able to see from here. And then if you press the graph again for k is 3, you can see it gets really wide here. So you might want to again change the view screen to see that, or you could also change the steps of k. And then if I change the steps here maybe to 0.1s, then you might see that change happening in a much more gradual way. You can see the graph's getting stretched out here. But obviously those x values are staying the same, so that's quite important to remember. So that should get you through some of the functions of the graph there and being able to have a look at how this works. So let's have a look at our final transformation that we could see, which is our reflections. So I'm going to exit until I get back to the graph functions, and I'm going to delete them all. So scroll up to them, F2 to delete, F1 to confirm, F2 and F1. And obviously we've looked at the sine and cos. Let's have a look at the tan function here. So first graph tan of variable x, exe to lock it in, and then we have a look at these two different types of transformations, the function of minus x and minus the function of x. So if I want f of negative x in the brackets, as you might expect, we need to set our graph up to be a function of our previous one. So while y2 is highlighted, we can scroll to the right, we can select that we want variable y, and we want to do it as a function of graph 1, so y1, and then we want it to be this minus x in brackets, so we just put in the brackets negative x. Now, it's a good habit to be in to not use the negative value here, not the minus sign for a subtraction, but the negative down here for brackets, and it will affect some of our later functions, probably not so much our trig ones, but it's a good habit to get into now. So use this negative when you want a negative number, and use this as our arithmetic subtraction. So we can put our variable x in the brackets, and we can see what's happened if our variable x turns into a negative x before the graph's done. Now, in this case, there's no variable to modify. We haven't put a k or any other letter in there, so we're just going to be able to draw the graph straight away and see what happens. And you should be able to see that we've got kind of a reflection of the graph going on. These curves that are coming downwards in blue are our original ones, and the red lines going opposite there. Now, you might want to look at a couple more graphs just to see exactly what transformation's taken place, but I will be running through that on the main slides as well. So let's have a look then at the other function, which was our negative at the start of the function. So we can go back in and change our original one here. And again, if you want to scroll, you can delete the whole thing and rewrite it. I'm going to press scroll to the right to get back into the function. And I'm going to put my negative sign there at the front. And then make sure you're using the proper negative sign one there. And then delete the negative sign from here. So scroll to the right, press your delete button. And then let's lock it in and then see what this graph looks like. Okay, this one looks very, very similar at the moment. So again, you might want to investigate some others. If you can't see a difference between these two functions, investigate some other graphs and see what appears on it, or zoom out. So you might need to investigate that one a little bit deeper yourself. But again, I'll go through that on the main slides. So we've got some other sort of questions here. So we show the calculator can be used for this because these are absolutely brilliant. You can get through a lot of these trig transformation questions and get high marks for them just by knowing how your calculator works. So I've got here the graph shows the curve y equals cos of x plus 30 between minus 360 and positive 360 degrees. Write down the coordinates of the points where the curve crosses the x-axis. So you might have a decent idea from graph transformation knowledge of where that occurs. But say, for example, we didn't, what I'm actually going to do is draw this graph on the calculator. So I'm going to delete the functions we were just looking at, and then I'll actually just type in y equals cos brackets variable x plus 30, close my brackets. We're already in degrees mode, so it'll be able to handle this. And then I'm going to press EXE to lock it in and EXE to draw it. There's a graph. So far, so similar. What I'll also want to do on this question, just to make sure I get some valid views on it, is to change my view window. This graph went from minus 360 to positive 360. So I'm going to change my view window and change the x values here. So I'm going to change it to minus 365. Now, why I've gone further than the minus 360 is if you put minus 360 in, it'll be absolutely on the edge of your display. So you might not see anything key that's happening there. So you might even want to go to minus 370, or minus 380 is going to be fine as well, 20 degrees out. And then I can lock that in with the XE. And I can change the maximum value, and again I'm going to get to 380 here, so I can clearly see what happens at 360. My scale I'm not going to change just at the moment, because I think maybe 90 degree graduations on the graph should be fine. And then the y values, we should know that the original value here is going to max out at 1 and go to -1 on the original graph. You should know what's going to happen roughly with the x plus 30. It's not going to change the height of the graph here. So maybe I can scroll down as well and change my y minimums to a minus. Oh, sorry, I've skipped on there. Let's exit that. Let's go back to our graph, sorry. Let's change our view window. You can see the x-axis already changed. Scroll down to our y minimum, and we can start to change that. So y minimum, I maybe want minus 1.2, and then y maximum, positive 1.2, and exe on those. Then if you exit and redraw the graph, it might be a lot more like the one we've got drawn here. Now, this is where we can get some nice functions going on the graph. It says write down the coordinates of the points where the curve crosses the x-axis. And this is where one of our real key things for the graphical calculator comes in. It will just tell us this automatically if you know what to input. This is going to be using our G solve button, the graph solver. So we're going to press shift here and G solve. and then it gives us a load of options. So we can find the roots of the graph, we can find our maximum points, we can find our minimum points, we can find our y-intercepts, we can find any intersections of graphs if you've got two or more graphs drawn on there. So it's really, really handy, really important stuff here. So obviously we want that when the curve crosses the x-axis, these are roots of a graph. So I'm going to press F1 for roots. You can see here that it tells us that x is minus 300, y is 0. So we've got our coordinate there. Now if you want that to stay on the graph, that pink point, and be plotted, you can actually press exe at this point, and you can see there that it's added that point in case you've got several, which we have. There's now going to be more than one root, so we can actually press the right hand button on our calculator and it scrolls to the next one. And then you can press exe again to lock that in, or you could write the numbers down straight from the bottom, minus 120, 0, and lock that in. Scroll along to the next root, press exe, lock it in, scroll along to the next root, exe, lock it in. So in the brackets here, we've got our 4 coordinates. Graph is solved where that graph crosses the x-axis. It also says find the coordinates of the point where the curve crosses the y-axis. So again, some of the people are going to have to do some trig functions on this. We can just go back and use our graph solve function, and then we can go to our y-intercept with F4. There we go. It's 0, and this is a real sort of key reason now. We've got y equals 0.866025438. Now it might not be that you recognise that number just yet, but the more and more trig, unfortunately, you're going to recognise horrible numbers like this to be equivalent to certain surds. So the rest of us are going to be maybe thinking how this one works. Let's have a look. We just keep those points. So we've got our translation points. Onto this part B. So when it's moved 30 degrees to the left, we're now crossing where x is 0. Obviously, you can sub-0 into that, and your calculator should give you root 3 over 2. There'll be a point it comes to later on in the course where you actually recognise that 0.866 is one of these key surds and key values that you've got. And that's why we know the exact values and have to look for them on our trig functions and be able to swap between. So they might want it in exact form in the exam, but you can just use this as a little checking point for it. So really, really useful stuff for you graphs on this. So you should be able to get those key points using this graph solve function. You can have a play around with that. Now, another thing you might need to do is get a graph of some quite complicated functions. Now, the kind of things you'll probably see are like 1D on your exam paper, but it's really nice and useful to lock in some marks by doing sort of partial bits of working out. Now obviously your graphical calculator can draw these graphs absolutely straight away if you type everything in, but it might be the case that you kind of take them step by step and use them in a kind of BIDMAS fashion to show you steps of working out. So if I was going to do question 1D on the calculator here, what we might want to do is draw a sketch. We've got the graph of sine x here. We might want to say, well, it's been changed. We've got a minus 4 at the front and we've got a 2x inside the brackets. So what we might want to do is actually draw first the graph of y equals sine x. So let's delete the original one. So let's put y equals sine x on the calculator, lock that in. That's going to be our blue line. We then need our 2x in there, so we can type that straight away. Y equals sine brackets 2x. That's going to be our red line, so we can see how that changes. And then at step 3, we need to include this minus 4 part for the whole lot. So type that in, negative 4 sine brackets 2 variable x. Close the brackets, and that's going to be our green line. So blue's the original, red's the next step of working, green's the next one. And then exe for those, and you'll see these are the things you need to sketch on your graph. Obviously you might want to just do those one at a time to see them more clearly. Now again, you can see here that by multiplying by minus 4, we've actually changed our graph by a scale factor of 4, so our y-axis here is actually no good for us. The x-axis is also a little bit off because this is only from 0 to 360. So let's have a look in the view window again, and then we want to change our x minimum to maybe minus 10. So we can see a little bit there. The max I'm going to put a bit closer as 370. Scale 90 should be fine for our purposes here. If you wanted to change it maybe to 45 or 30, you can see some of the key values kicking in if the graphs change that much, but 90 should be fine. And if we, sorry, I've gone off that. Let's go back to our graph, sorry. You can see they're a little bit better already. What I haven't changed here is our y values. Remember, if you change the graph by a scale factor of 4, it's going to get 4 times as big. So we really need our y values here to have a minimum of -4, so maybe a -4.2 so we can see a little bit further, and then a maximum of 4.2 so you can see where that goes. And then if you exe that, then you should get through. You can see the changes in those graphs there a little bit more clearly, so you should be able to get those sketched on in your graph in the exam with no problem. And again, if you're struggling to find any maximum or minimums, you can use your graph solve function. Let's have a look at some maximum points in our graphs. So you can scroll and exe them, and then it'll show the coordinates there. So I've scrolled to the green line here. It's found the maximum point at 1354. So you should be able to get that really sorted. The graph should help, these calculators should help you out absolutely immensely with the graphical functions. So that should get you through most of those if you want to have a play around with this and get your graph functions done. You've also got the ones here where we've got question 4, where we've got, this is a sketch of the graph a sine x plus b, and you can obviously use your calculator there to play around with it. It's good to have an idea of these trig transformations first so that you can have a look at that initially. But obviously you can then use your graphical calculator to check that you're right. So it's a hugely powerful tool when we get into this part of the problem. And obviously when these questions start to link in with some trig equations, it'll be much, much more useful as well for the graph solve function. So I hope this has been quite helpful for you. Obviously we've got the main slides as well to go through on the lesson, so if you'd like to have a look at those as well, we've got some of the more basic functions. Obviously this is a little bit of an interlude to help you out with the calculator use. Remember, you can give me an email or get us on Teams at any point you want. It's red@theroyal.school. I'm definitely online during our main lesson because we do have some students in, so feel free to pop us an email after you watch the videos there. But remember, this graphical calculator use is absolutely key at the moment. So get yourselves used to how this works. So there might be quite short activities when we look at these trig transformations, but the power that you'll get out of using this calculator or pay it forward in loads of other topics that we'll be covering. Hope to catch you next week, guys, and see you later.